This is the third lecture in our series from Chapter 12. This topic for today is going to be the first one about our fossil fuels, which is coal. Now, first of all, let's talk about where coal comes from. Well, the best guess that scientists have is that when organic matter begins to decay, in some regions it becomes heated and smashed, and then gradually through lots of heat and lots of chemical transformations becomes coal. So in this process, there are several types of coal. The first thing that's usually sort of lumped in the category of coal is called peat. Now it's not true coal, but it's the first step in coal formation. So this is when that organic matter is still actually identifiable, and it's usually plant matter. And as it initially becomes heated and smashed, it gets more and more dense and has a really high value as far as a fuel. So you could say that peat is the first step between a biofuel and actual coal. Now there are three other types of coal that are found in different regions depending on the types of plants that were present when the coal formed, and these three types are lignite, bituminous coal, and anthracite. Now lignite is a rare form of coal. It has a lower heat content than the other two types, so it isn't usually as valued as a fuel. Now bituminous coal is the most common form of coal. It's widely used, and it has a fairly high sulfur content because the plants that made up bituminous coal when it formed contained a lot of sulfur. And bituminous coal usually formed from plants that were found in what used to be an ocean. Now the most favorite type of coal is anthracite, and anthracite has a low sulfur content and a high heat content. So anthracite, if you had 1 pound of anthracite and 1 pound of bituminous coal, your anthracite would burn hotter for longer than your bituminous coal would. You'd get a higher heat content from anthracite. So because of its low sulfur content and also because of its high heat content, anthracite is the most prized form of coal, but it's also not very common. Bituminous is definitely the most common form of coal, and that's usually what we'll talk about. Now coal is mined in surface and underground mines. If you guys remember from Chapter 9 or Chapter 8 and 9, we talked about the different types of mining and the different types of habitat destruction that occur when those types of mining are used. Now, before we move on, quiz question for you. Which form of coal produces the greatest amount of heat and the lowest sulfur emissions when burned directly? Now, would that be A, peat, B, lignite, C, bituminous coal, or D, anthracite? Now, go ahead and pause there and choose your answer. And the correct answer is D, anthracite. So hopefully you guys all got that right. Now, in case you forgot what surface coal mining looks like, here's a picture. Remember that you basically just strip away all of the trees, all of the topsoil, and dig down into the coal seams wherever they're found. And after we've pulled all the coal out, the mining companies are required by law to restore the land to its original condition unless they go bankrupt. And you can bet that a whole lot of them go bankrupt without doing very much restoration. But a mine like this could be in operation for several years, 10 to 20 years, depending on how much coal is present. Now, once the coal has been mined, it's taken to usually taken to a coal-fired power plant. That's where the majority of our coal is burned, and it's burned to produce electricity. So the coal is brought in, if you notice on the left, and as it's brought through, it's put into a pulverizer where it's smashed down into little tiny bits, and then it moves from there into the boiler. Now in the boiler, the coal is burned at very high temperature, and it's used to turn water into steam. And all of the excess exhaust from that, you can see, goes up that tall smokestack. The exhaust gases include things like sulfur dioxide, carbon dioxide, particulate matter, the ash. Some of that ash that falls down to the bottom actually gets pulled up out the smokestack, the chimney stack. Now, after the steam is produced, it's kept under very high pressure, and it is channeled along through some pipes to where it turns a turbine. And you can see the picture of that the giant turbine up there. As the steam turns the turbine turns a generator, and a generator is basically just a big coil of wire with a magnet inside. So as the magnet spins, it creates an electric field in the coil of wire and produces electricity, which then gets sent out the transmission line to houses, businesses, other industry, things like that. Now the steam after it has turned the turbine gets passed down into a condenser. You can look right there in the middle of the picture in blue. It has a condenser. And in the condenser, they use cold water that's brought in from a cooling tower or a lake, a local lake or stream. They use cold water to cool the steam back down and condense it back into liquid water. So we have two separate circuits of water here. We have one circuit where the water becomes steam and turns the turbine and then goes back to the condenser. And then we have another circuit where cold water comes in and is used to condense the steam back down, and then the warm water exits the building. So the overall products of this process, we have all of the gases that we talked about that go out the chimney stack. We have warm water going back to whatever the cooling tower is, or if it was a lake. And then we have electricity being produced. And there's also ash. So just to make sure that you understand how coal-fired power plants work, go ahead and quiz yourself here. And remember, if you get these quiz questions wrong, you should probably go back and check scroll the lecture back and see what was going on there so you can figure out what you missed. So in a typical coal-fired power plant, how is electricity generated? Is it A, burning coal is used to move pistons in an internal combustion engine, producing electricity? B, burning coal produces oxygen, which can be burned in an engine, producing electricity? C, burning coal releases chemicals that catalyze a reaction in a large battery, producing electricity? Or D, burning coal heats water to produce steam, which turns a turbine and generator, producing electricity. So if you're not quite sure, pause, pick your answer, and the correct answer is D. Burning coal heats up water, which produces steam. The steam turns the turbine and generator assembly, and that is what creates electricity. Hopefully you guys all got that right. All right, so let's talk about coal in the world. Where in the world is all that coal? So it turns out that the United States, believe it or not, actually has almost 30% of the world's coal, 27% of the world's coal in the U.S. These are proven coal reserves, means that we know where the coal is, we know roughly how much there is, and we know that we can access it. Now, Russia has 17% and China has 13%. Given these numbers, you would assume that the United States would be the greatest producer of coal, but it turns out that China is actually the world's largest producer of coal. They have vast coal mines in their mountains, and remember from our first lecture that China is trying to supply enough energy for a rapidly developing and growing population. So the problem, and China's energy problem right now is not so much that it has so many people, but it's that each person is using more energy on a yearly basis. So overall, their energy demand is increasing like crazy. Now, our world reserves of coal are predicted to last about 300 years at our present rates of extraction and consumption. Obviously, if China increases their rate of extraction and consumption, they use more coal, then those reserves are going to last for less than 300 years. Now, as we're comparing coal with other energy sources, let's talk about the advantages and disadvantages. So first of all, the advantages of coal. There's a really large supply, and it's highly efficient. It has a very high net energy yield, which means that for a little bit of coal, we get a lot of energy out, even after you take out all the costs of mining and transportation. It's a well-developed technology. If you remember from our first lecture, we've been using coal since 1850. We've got a lot of practice with it. We do have some U.S. subsidies to keep the prices low, although coal is has such efficient energy that it actually would be competitive on its own. The U.S. government, though, uses subsidies to keep the prices down. And coal has the unique advantage of being stable and non-explosive. When you're comparing coal to oil and natural gas, oil is flammable, combustible, natural gas, explosive. So coal is a little bit better than either of those. And we have new clean coal technology that we're going to talk about, which can be used to reduce pollution. Now, the disadvantages of coal. Coal mining is very dangerous, even if it's surface mining, and it can cause erosion and runoff, and also decreased biodiversity because of the large amounts of habitat destruction. There are also some major byproducts that we mentioned that are air pollutants. So the first of all is fly ash. Fly ash is the ash that was too light to fall down to the bottom of the boiler, and so instead flies off the top. We also have mercury that's found in coal, and so when you burn coal, mercury is released into the atmosphere. Sulfur dioxide, which causes acid deposition or acid rain. There can be radioactive particles because basically if there was any radioactive material in or around the coal, even trace amounts, once you burn the coal, that radioactive material is going to be vaporized and fly through the air. Carbon dioxide, obviously, anytime we burn a fossil fuel, we will produce carbon dioxide. And then nitrogen oxides, which are gases like nitrogen oxide, which is NO, or nitrogen dioxide, so NO2. And then the last disadvantage for coal is that it's expensive to control pollution. We'll talk about clean coal in a little bit, but it costs a lot of money to put all of the scrubbers, the wet scrubbers and the filters and things on those smokestacks. So quiz question for you, and I realize this is going to be a little bit tricky, but try and pick out the one that has a false statement in it. So all of the following are drawbacks of coal except A, surface mining is destructive to habitat. B, combustion produces air pollutants like sulfur dioxide and particulates. C, coal has a very low net energy yield and therefore would not be economically feasible without large government subsidies. Or D, pollution control measures for coal-fired power plants are expensive. So pause and look for the false statement among those. And once you find it, go ahead and start the lecture again. And the correct answer is C. Coal does not have a very low net energy yield. It actually has a very high net energy yield. So remember, whenever we see the all of the following except questions, we're going to first start by looking to see if there's a false statement among them. So in this case, coal we know has a high net energy yield, and therefore it is economically feasible even without government subsidies, although the subsidies do help keep prices down. All right, so finally the future of coal, clean coal technology. Now, clean coal technology is widely being advertised as just as competitive as renewables because they reduce pollution. So the main things that they reduce are carbon dioxide, the air pollutants basically, carbon dioxide, sulfur dioxide, the fly ash, the heavy metals that are usually released into the atmosphere. There are two methods of reducing this pollution. The first one is called coal gasification, and the second one is called carbon capture and storage. The picture there on the left explains coal gasification. Basically, you put coal and oxygen and water into a gasifier, and that vaporizes the coal. And so it's burned in that gasifier. Sorry, it's collected from the gasifier and it's moved over, it's called syngas at that point, like synthetic gas, and it's transferred over into the boiler, which is number 2 on the list there. The boiler is used to turn the turbine, which generates electricity. And then they condense the gas there and remove the residual heat by using water. And then that water gets heated up so much, as they collect the residual heat to heat water, they heat the water up so much that it can then produce turn another turbine. So now we're actually getting 2 times the electricity, maybe not double the electricity, but we're getting extra electricity being produced from the fact that we use these hot gases first to turn a turbine, and then we use the hot gases to heat water, which only needs to get up to 212 degrees Fahrenheit, and then those gases are used to turn another turbine. So that does help increase the efficiency of coal gasification power plants. Now, the second method of cleaning up all of this coal and the coal emissions is called carbon capture and storage. So you have a typical coal-fired power plant over there in the picture on the right, and it's producing electricity, which is being sent to a local city. But then rather than allowing all of the gas and everything to escape into the atmosphere, what they do is they capture it in a pipe, and they run the pipe way, 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 way deep down underground, and then they pump all of the gas down underground. So the carbon dioxide is not escaping into the atmosphere, it's being stored underground long term. And the idea is that it's going to take a very long time for that carbon dioxide to work its way back up to the surface. So that's all we have today for coal. If you have any questions, let me know, and I will see you all in class.